Bismillahirrahmanirrahim. In this session, we will discuss quadratic graphs and some solutions on the basis of their graphs with some intersection of some lines. So we will solve these equations, quadratic graphs, and some relevant solutions. So let's start with question number 1. Draw the graph of this y is equal to x square minus 4x plus 3 for the values of x from minus 1 to plus 5, and use graph to solve the equation x square minus 4x plus 3 is equal to 0. And similarly, the question number 3, draw the graph is this y is equal to x square minus 2x minus 3 for the values of from x from minus 2 to plus 4, and use your graph to solve these equations. So x square minus 2x minus 3 is equal to 0, x square minus 2x minus 3 is equal to minus 2, x square minus 2x minus x minus 3 is equal to x, and x square minus 2x minus 5 is equal to 0. So we have to solve these 4 different equations relevant with this graph. So we will solve this first and third problem, and let's start. So this is draw the graph of this from the values of this to this. So we have this x value minus 1, 0, 1, 2, 3, 4, 5. Minus 1 to 5 is here, and we have corresponding y values by substituting the value minus 1 here in places of x, and then 0 and 1, 2, 3, and finally the 5 value, and we will have this corresponding y values, and we have plotted all these x and y on this graph, and we have obtained this parabolic shape curve. And from this curve we have in the b part x square minus 4x plus c plus 3 is equal to 0. Now we can factorize it. So this is minus 4 can be taken as minus 3 and minus x, so it becomes minus 3 and 1, so it is plus 3. So this can be factorized and obtain x minus 3 and x minus 1 is equal to 0. So this can be factorized as x minus 3 and x minus 1. So x minus 3 is 0 or x minus 1 is 0. If x minus 3 is equal to 0, then x is equal to 3. If x minus 1 is equal to 0, then x is equal to 1. So the solution is x is equal to 1 or x is equal to 3. So at y is equal to 0, here this is y, basically it was y is equal to x square minus 4x plus 3. So the y is taken 0. At this axis, x-axis, y is 0, and we have these two solutions 1 and 3. Graphically it is available, and by factorizing it is also available, the same. Now question number 2 is same, and now we are going to solve question number 3. Draw the graph y is equal to x square minus 2x minus 3 for the values of x from minus 2 to plus 4. Use your graph to solve these equations. So we have to draw the graph by substituting values from minus 2 to plus 4, minus 2 to plus 4. All x values are here, and the corresponding y values by substituting the values of x in this equation, and we have y values, and we have plotted this xy on this graph. So this parabolic shape is obtained. So this is the first part, a part, and now in a b part we use this graph y is equal to x square minus 2x minus 3, this parabolic shape. We have to solve the following equation number 1, that is x square minus 2x minus 3 is equal to 0, which means y is equal to 0. When y is equal to 0, y is always 0 on the x-axis. So on this x-axis we have this part 1, b part 1. Here we have this minus 1 and 3. So part 1 we have this x equal to 0, and this factorize, and we have obtained x minus 3 and x plus 1 is equal to, so x minus 3 is equal to 0 means x is equal to 3, and x plus 1 is equal to 0 means x is equal to minus 1. So at x is equal to minus 1, on this x-axis we have y is equal to 0, and here x value is minus 1, or y value or x value is plus 3. So at these 2 points the y value is 0. So the solution is x is equal to 3 and or x is equal to minus 1. So this is the first part. In the second part we have to find x square minus 2x minus 3 is equal to minus 2. So y value is taken as minus 2. So this is y is taken as minus 1, this is minus 2. At this point this is intersecting here and here. So we have to find at x is equal to minus, y is equal to minus 2. So this equation is equivalent to minus 2. So this minus 2 can be shifted here, and this becomes plus 2, and minus 3 plus 2 is minus 1. Now we can factorize and we can obtain, this is x square minus 2x minus 1. So we can add it 1 and subtract 1. So this becomes whole square, x minus 1 whole square minus 2 minus 1 minus 1 minus 2. So this is 0. So x minus 1 whole square is equal to 2. So x is equal to, this can be written as plus minus under root 2. X minus 1 is equal to plus minus under root 2, taking a square root on both sides. So this is, so x is 1 plus or minus under root 2. So for 1 plus under root 2, this is 2.414, and 1 minus under root 2, this is minus 0.414. So this value here we have minus 0.414. This is minus 0.414, and this is 2.414. This point is 2.414. So the second part where the equation is equivalent to minus 2. So this y is equal to basically minus 2, and this line is intersecting with this parabola here and here. So we have these two solutions for the second part. Let's go to the third part, where we have this equals to y. This is y, basically this equation is equal to y, so this is y is equal to x. So this y is equal to x is this line, straight line passing through this origin, intersecting here and here. So we have to solve this part 3. So in this part 3, x square minus 2x minus 5 is equal to also what I did here in part, where is part 3? Oh yes, part 3 is done in the letter section. Oh, this is part 4, so let's discuss part 3 first. So x square minus 2x minus 3 is equal to x. So this x is shifted here, this is part 3, and because y is equal to x, so this x is shifted here, so it becomes x square minus 3x minus 3 is equal to 0. And from this we can we can write this in this form. So this is x square minus 2b, and opening this we have this, and by equating it we have obtained b is equal to 3 upon 2 and c is equal to minus 21 upon 4. So this can be write down as x minus b plus c, and we have obtained b is equal to 3 upon 2, so 3 upon 2 here, and c obtained as minus 21 upon 4, and in c is minus 21 upon 4. So this equation is equal to this. So this is equals to 0. So this x minus 3 upon 2 minus 21 upon 4 on the other side is, because this is all equals to 0, so this is 21 upon 4, and from here we have x is equal to 3 upon 2 plus minus under root 21 upon 2, and from here on one plus side and the other on minus, and we have obtained these two solutions, 0.71 and 3.79, and that is available on the graph. So this is 0.79 and this is something 3 point something, which is here, these two solutions. In the fourth part, we have this is x square minus 2x minus 5. So this is minus 5 minus 3 and then added minus 2 here. So this is question number part 4. So this is minus 4, so this is minus 2 and this is 3. So it means y is equal to 3. At y is equal to 3 we have to find this. So this from this we factorize it, and from this we have obtained x minus 1 whole square by completing square, and like the other methods this is 6, and here we have x is equal to minus 1 is equal to plus minus under root 6, and this plus 1 plus minus under root 6, and we have solutions 3.45 and x is equal to minus 1.45, 3.45 and minus 1.45. So at x is equal to 3 we have one solution here and the other solution is here. So the two solutions, this line is intersecting, y is equal to 3 is intersecting this curve at this point. One point is here and the other intersecting point is here, and we have the two values obtained as 3.45 and 1.45. So this is question number 2 and very, very important. And let's move to question number 3, and let's solve question number 5. Draw the graph y is equal to 2x square plus 3x minus 9 for values of x from minus 3 to plus 2, and use your graph to solve these equations. So we have to solve this. So again y is equal to minus 1, so this is same here, and we have considered it minus 9. So this is minus 9, and we have this, we have changed it, and line is passing for someone. So if this is minus 9 means plus 5 is here, so plus 5 is on the other side, minus 5. So make it like this. We will draw it, we'll show it in our working. So in question number 5, so we have drawn this graph. So y is equal to 2x square plus 3x minus 9 for x is equal to minus 3 to 2. So this is basically the 2x square plus 3x minus 9 is drawn here. This graph is here, and we have drawn this graph, and the values are minus 3 to plus 2, and the values are plotted here. And at x is equal to, y is equal to 1, at y is equal to minus 1, so this is minus 1. At y is equal to minus 1 we have these 2 points, 1 point here, 1 point here, and we draw the graph, this graph here, but basically it is not required, but we can solve it the other way, which was y is equal to minus 5. So this is another way to solve it, but we solved it in a different way, so by intersecting these points. So either way we can solve. We did the same, we did the twice efforts here, so that better understanding can be achieved. So by using this graph, and by y is equal to minus values, we can obtain this graph also. So this is not very difficult. So this is minus 1. We did it for this part 1, and everything is there like this. And for this minus 4 we draw the graph, and we have obtained these values. So this is the same way, and we can draw this. We actually draw this graph we have drawn this graph here, this graph, and this graph again repeatedly draw this. But this graph is not required to draw, but this can be achieved through this by making this -9 and here -5, and we can just place this y is equal to -5 on this graph, and this graph basically gives the same results. Here x value is same is here, this x value is same is here, so we can draw this value from this simple graph also, from this single graph. There no need to draw this graph, so this is very important. So this second part can be answered from here. So I've just shown it in the working so that better understanding can be achieved in a regular working, but in an exam there would be no requirement to draw this graph. This single graph is sufficient. This line one, and for the second part this line is sufficient, and intersecting this and we can obtain the results. So in the next session we will discuss some remaining parts, and